Most homemade exoskeletons are built very rigid, and this is completely understandable for they provide less points of failure and are easier for single operational purposes. Not to mention they're quicker to manufacture in general. But I don't want a suit that is for one purpose. I want a more universal suit that can be used for longer periods of time, that can be more flexible to the wear, even when not powered, meaning partial passiveness if not total. So I built this. My suit allows for 3 points of articulation, allowing for more options in what the suit can be utilized for. Unlike very rigid exoskeletons, you can still do a fair amount of normal tasks while wearing this exoskeleton. An example being climbing a ladder. Sleeping. And making a peanut butter and jelly sandwich. This suit is still in the prototyping phase, as you can tell from the wood that's still currently on it. Manufacturing was quite simple in theory. Add cylinders to every point that is required for human articulation, and figure out the rest when the issues occur. After the last video of the spine, I start off with the shoulder. I had a rough idea of what I wanted, but I needed a physical measurement to confirm my ideas. Thus, I utilized wood to prototype and fit the mounting brackets for the arm placements. I'd recommend this to anyone who is prototyping because it's cheap and easy and you can just cut and modify as you will. If you notice in some of these clips, you see spikes that are on the shoulders. This is because the original idea was to utilize bike chains to lift the arms upwards. After realizing how much space it would take up alongside the back, I ended up scrapping the idea because I just added more cylinders to make it simpler. This is how the new bracket functions, and I am very proud of this. After making the first arm, I was so ecstatic to have it completed, so I tested it right away. The results were not as extravagant as I had hoped, so I did what any normal person would do, and I put it in the back of my mind and waited 6 months, got distracted, built a steam boiler, all while forgetting the reasons for my design choices and how I manufactured everything. Then I tried to recreate the second arm. When testing the first arm, I was having a lot of issues with it, the entire system just flexing all over the place, and it was really heavy on my shoulders. It eventually made me decide that I need to break down and fix my poor engineering for the connections of the spine. To do this, I just shoved a pair of football pads under the shoulders, and voila, the issue is mainly fixed. Now for some more data on the suit itself. The prototype arm can move upwards of 90 degrees from resting position. The biceps can move about 100 degrees. Oh, I just punched the microphone. The user can T-pose about 45 degrees while wearing the harness. These are all powered by 3 pneumatic cylinders on each arm, 1 for each moving component, and a spring on the passive nips for the bicep. This amount of movement is impressive, but it's not without its drawbacks, such as weight, mobility, and attaching to the wearer. So, let's dive deeper into the issues for a moment. First issue comes from the design of the human anatomy versus this design. When the user's arm is in the resting position on the sides, the suit matches the user, but when the suit's arms are raised up, the exo loses this match. I attempted to solve this issue. I just ended up settling with using these industrial drawer slides on the arms to the pilot. This issue occurred because the shoulders are higher up than the pilot's. I'm currently working on a possible fix for this issue. Okay, on to the next issue. Second issue is weight. Right now, the suit weighs around 27 pounds, maybe, I don't know, I didn't actually measure it. Without a surprise, it's all top heavy and back heavy. This has become an issue because the arms want to flip down when you kneel down. And a lot of times, they just want to hit you in the back of the head, which is not really fun. There's also an issue right now of there's too much yaw, but that's easy because I can just fix it with adding some more structural integrity to the spine. But a quick side note, I don't even know if the spine actually helps that much with lifting because I still need for the legs to be done to actually have the bottom help me. So that entire concept could just not work in general, and that would be awful. Okay, last issue. The arm connections are currently connected through a steel gauntlet on one arm that I use for cosplay and a elementary school shin guard that I have modified. The issues with these, of course, is it's not easy to actually have something that's reliable. And also, I've gotten trapped in the suit before where I couldn't move in any direction besides what I allow to actuate. I had to do this little method right here to get out, and it was awful. I hurt my back doing this little stupid method. I actually have a solution for this. Unlike those other issues right now, I'm working on it right now. And it's probably going to be the next video. So look forward to that. So in conclusion, the next part of the build, besides the connection of the wrists, come in forms of adding the power system, adding the air harness or the air tree, whatever you want to call it, and the legs. I have absolutely no idea what I'm doing for the legs. Maybe I'll just attach the long fall boots and I'll call it a day. But maybe not. First of all, I need to test the top to get out of the prototyping phase so I could figure out if the way that I have it now is actually worthwhile. So that's all for now. Thank you so much for watching. Please like and subscribe. I really appreciate it. And I am so happy they made it all the way through this. This project has taken way longer than it should have, and I'm happy to see it getting there. So please have a great day and love yourself. Bye.